This is a short video about exponential decay and growth and how you can use it in music. Um, there's a certain formula that I've used. I've tried many, but this is the one I like the most because it sounds it's very specific. It's very precise. And first, let's talk about the language. I'm using ChucK here. This is a musical programming language. And everything that's highlighted, that's the class that I've made that does a exponential echo for me. In this case it's a growth, so it makes an echo of any sound. You can put any sound into it. You can put your voice into it, and it does this. It's going to play it back with an exponentially growing echo. And down here is where I actually run the class, or it's where I implement it. So this is my sound chain. I have an impulse named imp, and that's ChucK to my class, and that's ChucK to DAC, which is a sound card. Then I can specify the parameters of my class here. So the first one, it's a float value. It's the feedback of each echo. So each echo is going to be 0.9 of the amplitude of the previous echo. So it's slowly going to fall off, and you can change this if you want it to persist longer. It's just like 0.99 or whatever. This is how many echoes are going to fall in the span of this amount of time. So I'm going to get 8 exponentially growing echoes in the span of 2 seconds. And what's nice about this is it's going to sound like the 9th echo should land where the next measure begins. So let's actually play this. So this while true loop is going to make a sound and wait 2 seconds, and it'll give it time for the echoes to play. Here we go. You can hear how the last echo is supposed to land, but instead the measure starts over, which is the effect that I was going for. And I'm going to show you the math on this graph so you can get 2 ways of looking at it. So this is the exponential function. This, by the way, this math here is exactly the same, or practically the same, as this line of code. This line of code does pretty much all of it. And then I have some other stuff to translate position to time, since ChucK uses time and not position. But in Reactor, it's actually easier. If you want to translate this to Reactor, in Reactor you usually use not time but position when you sequence things, so it's even easier to use there. And I'm sure you can translate this easily to max MSP if you wanted to. But the math, again, you can see at x equals 0, y also equals 0, and at x equals 8, y also equals 8. And in between those two values, those 2 points, is where our curve lies. So if we change x right here to 8, we get a nice line right at 8, which is perfect. And I'm going to show you the decay example. This is the one that sounds like a bouncing ball. All I do is, instead of counting from 0 to 8, I count downwards from 8 to 0. There isn't much of a difference in the code. Also in this example I do 16, it just sounds better, and it gives a better bouncing ball effect. Again, it's very precise. You don't get any bleed over into the next measure. And here's both going at the same time with a downbeat. Cool. I'm going to leave you with a piece I wrote in ChucK using this. So here's where I call the classes. I also call a BPM class. And then I add the score. And the score calls a whole bunch of other ChucK programs. And that makes up the composition.